Relativity sets limits on what humans ultimately can do. It is not required to be in perfect harmony the universe with human ambition.
Before Einstein, physicists thought that there were privileged frames of reference, some special places and times against which everything else had to be measured. Einstein encountered a similar notion in human affairs, the idea that the customs of a particular nation, his native Germany or Italy or anywhere, are the standard against which all other societies must be measured. Pretty interesting pictures. But Einstein rejected the strident nationalism of his time. He believed every culture had its own validity. And also in physics, he understood that there are no privileged frames of reference. Every observer, in any place, time, or motion, must deduce the same laws of nature. In the real world, we can never reach the speed of light. The commandment here is still, thou shalt not travel faster than light. But we can do thought experiments on what happens near the speed of light. Here, you can't break the laws of nature. There are no penalties for doing so. The real world, and this one, are merely so arranged that transgressions can't happen. The job of physics is to find out what those laws are.
This region of northern Italy is not only the cauldron of some of the thinking of the young Albert Einstein, it is also the home of another great genius who lived 400 years earlier, Leonardo da Vinci. Leonardo delighted in climbing these hills and viewing the ground from a great height as if he were soaring like a bird. He drew the first aerial views of landscapes, villages, fortifications. I've been talking about Einstein in and around this town of Vinci, in which Leonardo grew up. Einstein greatly respected Leonardo, and their spirits, in some sense, inhabit this countryside still. Among Leonardo's many accomplishments in painting, sculpture, architecture, natural history, anatomy, geology, civil and military engineering, he had a great passion. He wished to construct a machine which would fly. He made sketches of such machines, built miniature models, constructed great full-scale prototypes. And not a one of them ever worked. Mainly because there were no machines of adequate capacity available in his time. The technology was just not ready. The designs, however, were brilliant. For example, this bird-like machine here in the Leonardo Museum in the town of Vinci. Leonardo's great designs encouraged engineers in later epochs, although Leonardo himself was very depressed at these failures. But it's not his fault. He was trapped in the 15th century. A somewhat similar case occurred in 1939, when a group of engineers calling themselves the British Interplanetary Society decided to design a ship which would carry people to the moon. Now, it was by no means the same design as the Apollo ship, which actually took people to the moon some years later. But that design suggested that a mission to the moon might one day be a practical engineering possibility. Today, we have preliminary designs of ships which will take people to the stars. They are constructed in Earth orbit, and from there, they venture on their great interstellar journeys. Einstein wondered what the world would look like if you could travel on a wave of light. To travel at the speed of light. What an engaging and magical thought for a teenage boy on the road where the countryside is dappled and rippling in sunlight. Couldn't tell you were on a light wave if you were traveling with it. If you started on a wave crest, you would stay on the crest and lose all notion of it being a wave. Something funny happens at the speed of light. Because time slows down close to the speed of light, special relativity provides us with a means of going to the stars. The more Einstein thought about such questions, the more troubling they became. Paradoxes seemed to pop up all over if you could travel at the speed of light. Certain ideas had been accepted as true without sufficiently careful thought.
One of those ideas had to do with the light from a moving object. The images by which we see the world are made of light and are carried at the speed of light, 300,000 kilometers a second. If I'm moving towards you faster than a horse and cart, then my image should be approaching you exactly that much faster. My image ought to arrive earlier. But in reality, you don't see any time delay. But how would it look if it were proper to add the velocities? In precise laboratory experiments, scientists have never observed any such thing.
If the world is to be understood, if we are to avoid logical paradoxes when traveling at high speeds, then there are certain rules which must be obeyed. Einstein called these rules the special theory of relativity. Light from a moving object travels at the same speed no matter whether the object is at rest or in motion. Thou shalt not add my speed to the speed of light. Also, no material object can travel at or beyond the speed of light. There's nothing in physics that prevents you from traveling as close to the speed of light as you like. 99.9% the speed of light is just fine. But no matter how hard you try, you can never gain that last decimal point. For the world to be logically consistent, there must be a cosmic speed limit.
A shockwave, a small sonic boom in the Italian countryside. A thunderclap has a similar origin. So does the sound of a supersonic airplane. So why is the speed of light a barrier, any more than the speed of sound? The answer is not just that light travels about 1,000,000 times faster than sound. It's not merely an engineering problem like the supersonic airplane. Instead, the light barrier is a fundamental law of nature, as basic as gravity. Einstein found his absolute framework for the world, this sturdy pillar among all the relative motions of the cosmos. Light travels just as fast no matter how its source is moving. The speed of light is constant, relative to everything else. Nothing can ever catch up with light.
Einstein's prohibition against traveling faster than light seems to clash with our common sense notions. But why should we expect our common sense notions to have any reliability in a matter of this sort? Why should our experience at 10 kilometers an hour constrain the laws of nature at 300,000 kilometers a second?
Since near the velocity of light, we cannot simply add speeds. The familiar notions of absolute space and absolute time, independent of your relative motion, must give way. That's why, as Einstein showed, funny things have to happen close to the speed of light. There, our conventional perspectives of space and time strangely change. The most bizarre aspect of traveling near the speed of light is that time slows down. All clocks, mechanical and biological, tick more slowly near the speed of light. But stationary clocks tick at their usual rate. If we travel close to light speed, we age more slowly than those we left behind, distorted and redshifted. When he slows down, everything again looks normal. Only very close to the speed of light does the visible world get squeezed into a kind of tunnel. You would really see these distortions if you could travel near the speed of light. Someday, perhaps, interstellar navigators will take their bearings on stars behind them, whose images have all crowded together on the forward view screen. Atomic particles traveling near the speed of light do decay more slowly than stationary particles. As strange and counterintuitive as it seems, time dilation is a law of nature.
On the 17th of October 1933, Albert Einstein moved to the United States in the wake of Adolf Hitler's appointment as Chancellor of Germany earlier that year. Einstein, who was Jewish, was undertaking a visiting professorship at the California Institute of Technology in Pasadena when Adolf Hitler was appointed Chancellor on the 30th of January 1933. With the Nazis expanding their power in Germany, Einstein chose not to go home when he returned to Europe in March. When his ship docked at the Belgian port of Antwerp on the 28th of March, he renounced his German citizenship by handing in his passport at the German consulate. While the Nazis seized Einstein's cottage and converted it to a Hitler youth camp, the government barred Jews from teaching at universities, and the German Student Union burned his books. With a bounty on his head, Einstein stayed in Belgium for a few months before moving to Britain, where he was guarded by his friend, naval officer Commander Oliver Locker-Lampson. While a refugee in Britain, Einstein lobbied foreign governments and universities to find employment for former German Jewish scientists. While places were found around Europe, with over 1,000 German Jewish scientists being placed in Turkish universities alone, Einstein himself was refused British citizenship and instead accepted an offer from the Princeton Institute for Advanced Study in New Jersey. He departed England on the 17th of October 1933. Although Einstein initially intended to only stay in the United States for a short time, in 1935 he chose to seek American citizenship, which he gained in 1940. By this time he had warned President Roosevelt about the danger of Hitler developing nuclear weapons and encouraged the United States to begin its own research.